All right, today we're going to talk about the relationship created between different pairs of angles. So an angle bisector is a ray that divides an angle into two congruent, remember congruent means equal, two congruent angles. Okay, so if we have an angle here, and my lines aren't going to be super straight, so we'll get this angle here, and we'll call this angle A, B, C. All right, and then I have a bisector here, goes through, we're going to put a point out here called X. So we know that ray BX, remember that's how we write the ray BX, bisects angle ABC, okay, and that creates two congruent angles here and here. Remember those little partial things mean angles are congruent. So angle ABX is congruent to angle CBX. Okay? Vertical angles are formed by two straight lines. The angles are directly across from each other, and vertical angles are congruent. Okay, so move this up here. Let's see. So two straight lines, make these as straight as I can. So if we have line 1 here, and line 2 here. Let's try that one again. It's not very straight. Here and here. Okay. We'll give these all points. M or N, O, M, and P. Okay, so we got two lines going through. They intersect at this point here. We'll call this A. So then this and this are congruent. That's one set of vertical angles. And this are another set. So we would say angle NAP, our napping angle, is congruent to angle OAM. And also angle NAO is congruent to angle PAM. Okay? Complementary angles. Complementary angles are two angles whose sum is 90 degrees, or we know that is also called a right angle. One angle is the complement of the other, okay? So complementary angles form a 90-degree angle. So let's draw a 90-degree angle here. So one and the other there. We'll put my little right angle symbol there, so I know this is a right angle. And we'll label W, this point Q, and down here is R. And if we have a ray that comes through this angle, we'll just put it out like this. All right, we'll call that B, so that's ray QB. All right, so then angle WQB and angle BQR are complementary. All right, and they are complementary because the measure of angle WQB plus the measure of angle BQR equals 90 degrees. Okay, so two angles that are complementary add up to 90 degrees. All right, similarly, we have supplementary angles. Supplementary angles are two angles whose sum is 180 degrees, or what we call a straight angle. Straight angle or straight line, and we say one angle is the supplement of the other. Okay, so here we'll draw our straightest line that I can. All right, this is line A, B, and it also has point C on it here. And this angle comes out here. We'll have this ray CD. Sorry, that was supposed to be a D. There we go. All right, we'll say this is angle 1 and angle 2. All right, so in this case here, these are supplementary. So angle 1 and angle 2 are supplementary. And the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, so that's what it means for those to be supplementary there. A linear pair are two adjacent, just two angles next to each other, whose non-common sides are opposite rays. Okay, so that is essentially what we have up here in our picture up above. All right, these form a linear pair. Okay, A, C, CB, so that ray CB and the ray CA, those are opposite rays. That is not their common side, but the common side is that CD, okay, that ray that goes up through the middle there. All right, some examples, some practice down here. So this tells us that BD bisects ABC, so let's draw angle ABC. Doesn't really matter exactly how it goes here. We just want the angle. Okay, A, B, C. All right, and then let's see, BD bisects that. So B is our line in the middle there. So to get that, or get that point there, we'll just draw our ray bisecting here. So there is our D, BD bisects. Okay, remember if it bisects, and my picture isn't very good here, but it means that this and this are congruent. So my first example says that measure of angle ABD, okay, ABD, so I'll label that on here as 1, that's ABD, and the measure of angle DBC, okay, so we have that there, that's 2. Well, 1 is 5x, 2 is 3x plus 10. If that bisects, those angles are equal, so that means that 5x equals 3x plus 10, and then we can solve that equation. Okay, subtract 3x from both sides, we get 2x equals 10, divide by 2, x equals 5. So on our first one here, x equals 5. Okay? And we can follow that similar thing for each of these problems here.